Hi, I'm Doyle Bishop with Tulsa Heaters Midstream. On this channel, you can expect to hear about all things related to process heating, but sometimes the topics aren't technical, but most of the time they are, so thanks for joining. Hi, I'm Doyle Bishop with Tulsa Heaters Midstream. Today I want to talk to you about the concept of multi-passes. Maybe you've heard this phrase thrown about and you had no idea, or maybe you do know. If you bear with me, let's go through this, and at the end of this, we'll all know what multi-pass means and all the various nuances related to multi-passes. As a heater designer, as I look at designing the coil, I have two things that I really have to focus on. One is obviously the heat transfer. I have to make sure that there's enough surface area of this coil to get the heat into the fluid that you've asked for. Effectively to raise the temperature of the fluid from, let's say, 300 degrees to 400 degrees. I have to make sure there's enough surface area to do that. The other thing that I need to do is look at the hydraulics of that, meaning, hey, how big does the coil need to be for this amount of fluid to flow through it and not have too high of a pressure drop? So I've got to be able to get all the fluid through that coil that you want me to heat up within your pump capabilities. So I'm balancing that, and I'm trying to figure out, hey, what's the right size coil? Should it be just a big coil containing everything, or should I break it up into multiple coils? Whoever came up with the term multi-pass, I think they probably would have been better served if they had called it multi-path, P-A-T-H, because that's really what it means. When I bring the fluid into the heater, do I want it to branch into separate coils and then join back up at the end of the heater to connect up to your piping system? You'll follow me here on this sketch. Our heaters, and any fired heater you're going to buy, is going to be counterflow, meaning that the coldest fluid that you're trying to heat comes in to the coldest area of the heater, and then it works its way down. So the coil, the fluid in the coil is going this way, while the flue gas you can see is going up. That's counter current. You can see the circle that I've drawn here represents a header or a manifold. Many times you have a header and then it branches into multiple coils. The concept being is I'm going to have, let's say if it's 3-pass, multi-pass, I'm going to have 3 parallel paths that fluid can take, and hopefully it's evenly distributed between all 3. A 3-pass coil would mean that I'm going to have a manifold at this location. This is called the inlet manifold, and then it's going to exit at the hottest portion of the heater. This is an outlet manifold. And manifold is simply like this kind of a log piece of pipe. Then I have a flange here on the outlet, say it's leaving, and then I've got, for a 3-pass, I'm going to have 3 coils that connect into that manifold, and they all join up. The fluid joins up in the manifold, and then it all leaves together. Essentially, you got this massive amount of fluid, splits up into 3 different paths, goes through the heater, comes back together in the outlet manifold, and then you make the connection on the outlet manifold, comes back together. So one of the questions is why do we do that? Why not just make a single path? It gets down to hydraulics. Let's take a hot oil heater, and let's say it's 1,000,000 pounds per hour. 1,000,000 pounds of hot oil would probably take a 12-inch diameter pipe, in that range. You can look at this heater design, you can see that I have a helix here in our radiant section that I've got to bend. I've got to form that into a circle. Well, a 12-inch, just simply bending 12-inch pipe would require a very large circle, very large diameter, probably bigger than what I need for this flame volume. So if I bend that 12-inch coil, I'm going to end up with more space in this radiant section than really what I need. So economics would say, well, why don't you use a smaller pipe and have multiple passes? And the way that works is these end up being essentially multiple passes that are threaded together in here so that I have, let's say, instead of one giant 12-inch, I've got 3 6-inch. Now I can roll that pipe into a more reasonable diameter or smaller diameter, and I can make this radiant section a more economic size than I would if I used a single coil. So the big driver for us is really just the geometry of that helix. Just doesn't make sense to go really large and have an extra oversized radiant section. So let's think about that. What problems could I have? Let's go back up here, and I'm gonna just draw the inlet. Let's call this the inlet manifold, which you're gonna connect up to. And I've got 3 here come out. So this is the inlet coming in, inlet, outlet. One of the things that I would like to have happen, and really has to happen, is I've got equal flow in each pass. I don't want uneven flow, because think about that. If this pass carried 60% of the flow and these were 30 and 30, which pass would get hotter? These 2 passes would obviously be hotter than this pass because they're taking away less heat, and hotter maybe to a point where I have fluid temperature problems or material problems. So having these the same flow is really important. You know, like they're all 33% would just be perfect. There's a couple of different ways to do that. First is you want to make the geometry of each pass the same. You don't want to add extra elbows or extra length of the coil. You want to make every attempt to make that symmetrical in the coil. But that's not a guarantee, because you can't get perfect symmetry, but you can get close. Another step that you can take is you can put in balancing valves. So I'm going to measure the flow in each pass, and then when I find out, hey, this pass is flowing more than the other pass, I'm going to come up here and I'm going to pinch back on this valve a little bit and balance out that flow. So those are called balancing valves. For those to be of any use, you have to have flow meters on each pass as well. This is fairly routine. We don't do that on every heater, but we do it on a fair number of heaters where we have a flow meter and a balancing valve to make sure that if I design a multi-pass, I don't have a maldistribution in one coil over the other, because bad things could happen. Lastly, I want to say that we will make every attempt to do it in a single pass, because what a single pass will allow you to do is to have almost unlimited turn down. If I have a multi-pass system, as I start turning the flow down, I get maldistribution of flow. Whereas if I have a single pass, I can easily go 5-to-1 turn down, and it gives you more flexibility on your heater to go with a single pass. So we'll make every opportunity to do a single pass. We'll do a multi-pass heater only when we need to. Hey, thanks for joining. If you enjoyed this episode, hit like or subscribe to get more information about process heating and Tulsa Heaters Midstream.